share screen. Hi, my name is Christopher Tapia Carmen, and this is my Physics 2212 Lab 3 circuits. The content of this lab include purpose, procedures, physics, error, and questions that may arise. The purpose of this lab is to analyze circuit structure and behavior, use a multimeter to measure current, voltage drops, and more, and then understand capacitor and resistor behavior within circuits. The physics behind this lab include the loop rule, which is the sum of all voltage drops around the loop is equal to 0. The node rule, which means that all the current going into one intersection must equal the current going out. And then Ohm's law, which is voltage equals current times resistance. Equipment needed for this lab are transistors, wires, batteries, phone, or something to record. A multimeter, capacitors, and light bulbs as well. For this lab, we use 147 ohm resistors, capacitor of 1 farad, and light bulbs which were 8 and 33 ohms. So for the first circuit, you need 2 resistors, the ammeter here, and the ammeter there as well, and then 2 batteries of 1.5 volts each, 3 volts together. You need a 47 ohm resistor here, and then a 100 resistor here, and then we're trying to measure the voltage drop from each of them, so you check it at each of these ends for both of the resistors. We got 0.87 for the small resistor, the 47 ohms, and then 1.88 for the bigger resistor, the 100 ohms. For the RC circuit, the capacitor is 1 farad, and then the resistor, or the light bulb is, ours was like 33 ohms, but yeah. So for our videos, the first one took around 36 seconds to fully discharge and recharge. This was the small one, the like 8 ohm light bulb, and then the other one took like 2 minutes and 30 seconds. So, and it was around 33 ohms, so it was exponentially greater. So the math behind this is, theoretically, it should take, the voltage drop between the first resistor should be 0.96 volts, and we got 0.87, so this was pretty close. And then behind the second resistor, it should be 2.04, and we got 1.88, so that's pretty accurate as well. The capacitor, the time it takes for the capacitor to recharge and discharge should be exponential, like seen right here and over here as well. Bulbs were 8 and 33 ohms. That's pretty much it for this. Error could include unaccounted resistance, like wires being bent or something like that, timing delay, and then component flaws as like temperature and more can mess with the actual resistance. Questions: what if you charge the capacitor with no resistor in the circuit? How quickly would our ideal model predict the capacitor to reach full charge? Would this prediction happen in real life? Explain. It would instantly charge the capacitor because R would be 0, and so volts would just be V over 0, which it'd give you like infinity. So, yeah. Thanks for watching.